This last example is kind of an all-encompassing Chapter 4 review example. It'll go over every single topic and concept, more or less, that we learned about in Chapter 4. And so it's really a nice way to review for your exams and also just kind of make sure that you understood everything that was going on with bivariate data sets. All right, so let's look at this data set. This is UNESCO, which collects data from countries on their female literacy rate, i.e. the percentage of women in a country who can read and write, and their fertility rates, right, the average number of children per woman. So the following results come from different countries in 2007. The first few data points and the corresponding scatter diagram are shown. So I don't have all the countries in here, obviously. I have a lot of them removed. You can tell that by looking at the scatter plot over here on the right, and you can see there's way more dots than 6. So I obviously have removed a whole bunch of them. That's what those little dots mean. That means I want you to rely on the computer output, which you see down here, and the graphs, rather than typing it in yourself into a computer or a calculator. Now I'm giving you both the outputs in this program up here. This is this is StatCrunch, which is often used for this course. It's a nice student-centered way of viewing data. But I also have down here Minitab. Minitab is a computer program that is used by a lot of places as well. All right, so first we begin with what is the sample size? And how could you find it from the computer outputs and graphs? So I get this question a lot. So you have to kind of roam around. Now in the StatCrunch output, you can actually tell how many pieces I was using. But in the Minitab output, you can't. So the Minitab output does not say the sample size anywhere in it. But the StatCrunch output does. So that's the first thing we want to notice, is that the StatCrunch output has sample size right there at 112. There, I kind of highlighted it in purple for us. All right, so down here we'll say 112. Now you can tell it from the StatCrunch output because it's given to you, but if you didn't have the StatCrunch output, you would have to actually literally try to count the dots. That's how you can tell. Count the points on the graphs. That's the best you can do. So it's not great, but I wanted people to have, you don't really have to go through and count every single dot, but you can tell that it's over 100, right? Not by much. I mean, it looks kind of close to 100. All right, letter B says, what is the explanatory variable and its units, and what is the response variable and its units? All right, so the explanatory variable is your X, which was the female literacy rate, and the response variable was your Y, which is the fertility rate. And the units, I mean, percentage isn't really much of a unit, but we'll go with it. And then the children per woman. All right, so let me go type that up. There we go. Now that female literacy rate that we're looking at, and we want to kind of describe that variable in terms of what type it is. So female literacy rate is right here. And you can see there's lots of decimal places. That's because this is an average rate for a whole country. So they're basically taking the number of women that can read and write in their entire country and trying to gauge that against, the number of women, period, in their entire country, and then also get the number of women that can read and write, and then try to divide. And so it's a rate representative of a whole group, but it has a lot of decimal places because it's something you're trying to measure about your whole population. That means that it's going to be quantitative continuous, right, because it's a measured item. And then it also has to be ratio because it's a numerical item, right? Numerical quantitative is almost always interval or ratio. And then it can't be interval because it can't have negative, right? You can't have a negative percentage of women that can read and write in your country. All right, next, the coefficient of determination. So when I ask you this question, I'm making sure that you know which one the coefficient of determination is. And that would be r squared. R squared is your coefficient of determination. So you can see it in the StatCrunch output right there, 0.56436761. You can also see it down here as 56.4%. So those two things together let you know what your coefficient of determination is. I'm going to highlight them in like a yellow box so you can see them. There, I highlighted it in the notes, and then I'm back here, I put the r squared box right around that one or right around this one. And just for the record, ignore the r squared adjusted. We don't use it. It's not a thing for us. So don't pay any attention to that one. There, I put a slash through it so you guys could know. So ignore that one. Don't pay any attention to the adjusted. Always look to the r squared. RSQs, SQ stands for squared, or up here, RSQ, r squared. That's your coefficient of determination. All right, so then it wants us to interpret that coefficient of determination. Well, that's that very formal phrase that we learn in section 4.3, which says that 54%, or excuse me, 56.4% of the total variation in the fertility rate, the y variable, from country to country can be explained by the least squares regression model. It was the first page in section 4.3. You want to make sure that you have that formal interpretation box for r squared on your notes somewhere for your exam, because you don't have to memorize it, you just have to be able to use it. So you can call it the least squares regression model, or the linear regression model, or whatever. We know what you meant, the line of best fit. All right, next. We need to calculate the correlation coefficient from r squared. Well, the correlation coefficient is r. So they're saying basically find r from r squared. Well, r is the square root of r squared. But remember from when you're in algebra class that you have to, when you take the square root of something, take the square root of both sides, it's plus or minus. So give me 1 second. All right, so I'm just going to make that a little comment right here. So recall, you choose the plus or minus based on context. So we want to take the plus or minus square root of our r squared value, which is, okay, and then the other thing you want to do, it's 0.564. A lot of students make a mistake, and they use the percentage. So I'll make another note. Be sure to use the decimal r squared value, not the percentage of r squared value. Percentage r squared value will not give you the right answer. There, I made a little warning for you for this calculation. Be extra sure to use the decimal. So that means that instead of taking the square root of 56.4, I'm going to take the square root of 0.564, which I already found is 0.751. So if I look at the context of this problem, actually I don't want to use plus or minus. If I look at the context of this problem, I can actually see it has to be negative. And the reason it has to be negative is because the slope of our line is negative. If you look at the scatter plot, right here, you can see it has a descending line. You can also see it in the equation for the line. The slope is negative 0.04866. So either way, right there, negative 0.0487. So we have a descending line, so I'm just going to write that right now. There, and I just made a little note about that. So we had the square root of 0.564, which I'll bring up the calculator just so you can see. But it's the square root of square root of 0.564, and then you make it negative. So that's negative 0.751. And just so you can see it on the calculator, to remind yourself, it's second, the x squared button has the square root. So second square root, 0.564, enter. And then I just rounded it. All right, now given that relationship that we're seeing, looking at that scatter diagram and that linear correlation coefficient, what type of linear relationship exists? Well, it's negative, right? It's a negative linear relationship. So let me highlight that. And then how strong is it? Well, for strength, you can actually go and look at either the correlation coefficient or the coefficient of determination. We have a whole list of the numbers that make it so that it's strong, moderate, weak, etc. As a matter of fact, I'll scroll back to the one for R, just for starters, and then look at that. So here we have this picture in section 4.1, and you can see that a negative 0.75 is right here in moderate negative zone, right? So you're over in the moderate negative area, this area right here, that blue zone. So that's one way you could see it, just by looking at the negative 0.75. You could also look at the r squared value. So let me go to that picture right here. And since our r squared is like 0.5 and some change, we know that we're in the moderate relationship right there. So that's where we're at. So we're in the moderate zone. So either look at the r squared, the 0.5 and change, looking at this group, or the 0.75 and the other, right? Don't mix and match them, right? So compare r squared to this group, right? This picture, this table. Compare r in the other table. And that's why I highlight moderate right here. All right, now considering the residual plot, was a linear model appropriate for this data set? Explain. All right, so let's go look at the residual plot. So the residual plot's right here. It's not great, but it definitely doesn't show a parabola or a curve pattern or anything like that. So that's all right. We run into a little bit of problem. It's not horn shaped really. I mean, it has a little bit of an issues with the outliers down here and a couple outliers up here on the top, up near the word literacy, and then kind of down here near the 40 and 50. But other than those, it's pretty evenly scattered. There is some clumping over here that maybe you could analyze in a different way. But for the most part, yeah, it's all right. I mean, it's not perfect, but we don't really expect perfection anyway. We're in statistics, not algebra. So if for our purposes, it seems like it's fine. It doesn't seem to have a cone shape or a horn shape. It appears to be random, which is good, right? You want it to look like the points are just kind of thrown up there.